Zuzuro. So today I am going to explain to you about the introduction of our assignment 3. That is mainly about computer vision. Generally, computer vision is a pivotal branch of artificial intelligence, which enables computer to analyze, interpret, and derive the insight from the images or videos. From this computer vision, we use deep learning model for image detection. The objective of this assignment is to enable the model to detect and classify images, and we only focuses on cats and dogs. The second objective of this project is to allow the model to learn the features of the cats and dogs by interpret the shapes, colors, and the texture of the animals. Next, for the dataset in this assignment, we use dataset from PASCAL VOC 2012, and for this task, we only focus on cat and dog classes to extract images for analysis. We use these two type of classes just to narrowing the amount of the data. So I will pass this presentation to the next presenter. Thank you.
So for algorithm, we started by selecting the cat versus dogs dataset from TensorFlow dataset, which contain label images for binary classification and object detection. The images were resized to 320 multiple by 320 pixels to fit the input requirement of the SSD MobileNet model. This resizing step ensures consistent dimension for better training and prediction. Next, we normalize the images and map object labels, either cat or dog, to numerical values. The pre-trained SSD MobileNet model then automatically predicted bounding boxes to locate these objects in the images. The SSD MobileNet V2 FPN Lite 320 multiple 320 model was chosen for its efficiency in detecting objects at different scales. It used convolutional layers to extract features and a feature pyramid network for multi-scale detection, helping to accurately classify objects while predicting their location. During training, we split the dataset with 5% for training and 5% for validation. Ensuring quick evaluation, the combination of classification and localization losses help balance object detection accuracy and bounding box precision. By visualizing the detection result using OpenCV and Matplotlib, we confirm the model's ability to accurately identify cats and dogs in the images. This algorithm efficiently leverages TensorFlow, powerful tools for object detection tasks, showing strong potential for further enhancement. The code implementation for our object detection model using TensorFlow and the cat versus dog dataset. I will explain the purpose of each part step by step. First, we begin by installing and importing necessary libraries. These include TensorFlow for building and training models, TensorFlow datasets to easily load pre-built dataset, OpenVC for drawing bounding boxes on images, and Matplotlib to visualize the result. And then, next, we load the cat versus dog dataset, splitting it into 5% for training and another 5% for validating to evaluate model performance. To ensure efficient object detection, we load a pre-trained SSD MobileNet model, which is optimized for speed and accuracy. To prepare image for the model, we resize them to 320 multiple 320 pixels. Convert them to an appropriate format and add a batch dimension for easier processing. Then after that, we detecting object bounding boxes need to be drawn around detected animals. This function extract coordinates, confidence scores, and class level to visualize the result for this one. Okay, and then finally, we visualize detection result by processing a few sample images, running them through the model, and displaying the result with a bounding boxes for this one. This demonstration shows how we successfully detect animals in images. Leveraging TensorFlow's pre-trained models and efficient data handling technique, potential improvement include optimizing batch sizes, experimenting with learning rates, or even augmenting data for enhanced model robustness. So we try to run this code and then wait for the code output to be shown. So we run this code and the output show images of cats and dogs with the boxes drawn around the detected animal. Each box has a label for the predicted class, which is like cat or dog, along with a confidence score showing how sure the model is about the detection. We set a confidence threshold of 0.5 so only reliable detection are shown. The SSD MobileNet model helps detect objects at different scales and works well for these stars. These results show how we can use TensorFlow and CNN models for accurate object detection.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Nabila Radia binti Ahmad Rizwan, metric number 2213554, and I will be explaining the experimental setup of this coding. There are three parts, which is the training process, testing process, and evaluation process. Firstly is the training process. The training process in this experiment focused on preparing the data and using a pre-trained model. We downloaded the cats versus dogs dataset and split it into two parts, one for training and another for validation. So instead of training from scratch, we used a pre-trained SSD MobileNet V2 model, which was already trained on the COCO dataset. This saved time and effort while giving us a good starting point. Next is the testing process. The testing process involves a pre-processing function which resized the image to 320 to 320 pixels, converted them to the required format, and added a batch dimension so that they could be used by the model. The testing process also involves applying the model to a small subset of 5 images from the dataset, and each of the image was pre-processed before being passed to the model, which generated predictions such as bounding boxes, which is to locate objects, class labels, which is to identify objects, and confidence scores, which is to show how sure the model was. Testing process helps us to see how the model performs on new data. Lastly is the evaluation process. In the evaluation process, we analyze the model prediction by drawing bounding boxes around detected objects and adding labels with confidence scores. We only showed predictions with the confidence scores above 0.5 to focus on the most reliable results. These images were displayed to visually check the model's performance. Through this, we could identify how well the model detected objects, as well as any mistakes like missed or wrong detections. This helped us understand the model's accuracy and areas for improvement. That's all for experimental setup.
Assalamualaikum everyone, my name is N.Fatihah, metric number 2210378, and I'll be talking about the conclusion for this project. To wrap up, in this project, we successfully built a deep learning model using Convolutional Neural Networks or CNNs to detect and classify images of cats and dogs. We used the PASCAL VOC 2012 dataset and TensorFlow's SSD MobileNet version 2 model to achieve impressive results. Our model performed with high accuracy, accurately distinguishing between cats and dogs. Not only that, but it has also localized these objects within the image using bounding boxes, which is a great feature for real-world applications. Through this project, we gain valuable insights into the importance of data pre-processing, efficient model architecture, and robust evaluation metrics for achieving top-tier performance. Looking forward, there are several areas for future improvement. We could explore techniques like data augmentation, transfer learning, and hyperparameter tuning to boost accuracy and generalize the model even further. Expanding the dataset or adding new object categories could also enhance its usefulness across different scenarios. Overall, this project gave us a solid foundation in applying deep learning to image detection and set the stage for future advancements in computer vision. That's all from us. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.